Okay, I'm going to finish up section 3.2. I did addition. This is now going to look at subtraction. So certainly you grew up with the takeaway model. You had 4 candies. Your brother came and take away 3. Suddenly, you know you're left with 1. Now the missing add-in model, I really don't agree with the authors so much with this one. Apparently, maybe I've interviewed more children than they did. But if you go back to that video of Nicole and the other 2 children, they did not do subtraction. When you had 6 stones and you got more, now you have 13. And the question is, how many more did you get? Sure, it looks like this equation. And sure, as adults, we've learned, it's probably taught to you actually this way, that 13 subtract 6 is 7. But to change this into a subtraction problem, when you're getting more of something, all of those kids used an additive strategy. So I'll put a question mark up by this one. Yeah, it can be done by subtraction, but it's not natural for young kids. Just kind of did examples of these anyway, but look at the action. Your brother takes 5 of them. Yeah, that's a takeaway problem. Now he gets some more. So the action is very different in these two. This one leads to subtraction. This got more. Well, you're getting something. That's addition. And kids tend to follow the action. The comparison model, that's another one. When I get to an example here, I'll talk about. Here we go. I have 7 pieces of candy and you have 3 pieces. How many more pieces of candy do I have? The problem with this one, and I interviewed enough kids to know that these are very confusing. There's no action here. You're not getting more, they're not taking away, and they don't know how to do it. It's very hard for them to gain entry to this problem. What I finally would get kids to do is they could put these blocks actually together. So they would have a string of 7, and then they could align them 1 to 1 with their 3 pieces, and then they could count and say, oh, it's 4. But there was no subtraction in the way they did this. It was just comparing and then counting. They didn't take anything away. Number line model, I think you're good with. There's takeaway, you bet. We covered this. Yeah, we can do it this way, but I'm not so sure that elementary kids would understand at all if you said that a getting more problem was subtraction. We can't force on them what they don't understand. Yeah, see, there's my claim. They may not subtract in either of these. Okay, this definition. So notice that we have 2 numbers, A and B. So A is greater than or equal to B. So we're talking about whole numbers. Again, here's our whole numbers. Let's take A equals 7, B equals 4. This definition says 7 subtract 4 is the unique whole number C. So in this case, we know C is 3, such that, remember this is A and B, B plus C equals A, which is 4 plus 3 equals 7. So this is a rather important definition because it relates addition and subtraction. They are inverse operations of each other. Basically what they do, get rid of this, let me get rid of another one. So if I do 12 subtract 5 is 7, that's because 7 plus 5 equals 12. Inverse operations, notice where I started. I started with 12 and I did subtraction. Then I did addition because addition undoes subtraction and vice versa. I started at 12, I did subtraction, I go back and do the addition, I get back to where I started, so they're inverse operations. I think you know a lot of these, multiplication and division. There's the comparison model. Okay, so if I was Juan and I'm doing this problem and I managed to line them up like this, I'm just counting 1, 2, 3, 4, 5. I didn't subtract anything. I really disagree that this is a subtraction problem. It's okay for you to think of it because that is one way to do it. But I don't see where the subtraction is. There's no taking away. It's just, okay, I'm comparing these. These are the same. I have 5 more than this other one. But I didn't take anything away because there's no action. Yeah, that's very important with young kids. Number line model, absolutely. Some of you probably learned it this way. Well, you start at 5, you're subtracting 3, so you go 3 units the other way, maybe 1, 2, 3 steps to get to 2. So right now, with this model, if you add 3, you're moving to the right. Add means move to right. 5 subtract 3, oh, subtraction, I move to the left. So then what happens later on when I do 5 subtract negative 3, and suddenly you're doing subtraction and you're moving to the right. That's when we get into integers and the negative numbers, that's where all the problems come into play. This closure thing, we'll finish with this. Set of whole numbers. If A is less than B, okay, 5 is less than 9, then A subtract B. 5 subtract 9 is negative 4. Negative 4 is not an element of the whole numbers, therefore, the whole numbers are not closed with respect to subtraction. I subtracted 2 members of the set. I did not get a member of the set back after I did the operation, so they're not closed. And that's addition and subtraction.